A woman is holding on to a rope above her head. This rope is connected to 3 pulleys and then connected to her feet. At what force must she pull to yank her feet out from under her? So as she pulls, she's pulling, getting less and less weight on her feet and less friction force, so eventually her feet come out from under her. We want to figure out exactly how much she has to pull at. So the key to this one is making a good free body diagram to start. So if we use our magic scissors and cut there, we're left with a tension force here, T, tension force here, T, and then the regular forces acting on her are her weight, the normal force, and the static friction force, which, since the tension force is pulling this way on her feet, the static friction force is that way. Okay, so we're given her weight and the static coefficient of friction. So all we have to do here is we have 1, 2, 3, 4, 5 forces. We can do some of the forces in each direction. So let's do the sum of the forces in the y direction first. Sum of the forces in the y direction equals 0, because there's no acceleration. No mass times acceleration. Acceleration is 0. So let's see what the forces we have. T, x, y, normal positive directions. So T is positive. We have minus weight. And we have, that's the normal force I didn't write, plus the normal force equals 0. So basically, if we're going to solve for anything, it'll probably be normal force, because we have an equation relating Fs and Fn. That's Fs equals mu Fn. So we have an equation relating those, so let's just solve for Fn. Normal force equals W minus T. Okay, Fs equals mu Fn, so we can plug stuff into here if we want, but let's do some of the forces in the x direction first, just to make sure we know what we want to plug in. Equals 0, because there's no acceleration. This is to the point that just at which her feet let go, so we have 0 acceleration. Some of the forces in the x. We have Fs in the positive direction. We have T in the negative direction. And that's it. Fs equals T. So what we can do is say we want to use this equation because we have her weight here. And we want to use this and this. So why don't we take Fs equals T and plug into this one. So what I'm going to do is plug this into here, then plug this into here, and then we'll have an equation just with the weight and the mu. So T. Fs is T, so I have T equals mu Fn. Then if I take T equals mu Fn and plug that in here, so Fn equals W minus T, and I plug in T into here, I will have, no, I don't want to plug T in, I want to plug in Fn. I have Fn equals T over mu. And the reason I don't want to plug T in is because then I'll just have mu Fn here, and I can't get rid of my Fn because I don't know what my normal force is. So I have to use something that will get rid of it. So I'm going to use T over mu in for Fn. So I have T over mu W minus T. So we have mu is 0.65, T over 0.65 equals W, which is 750. Minus T, and we're trying to solve for T because we want to know what she has to pull at. So I'm basically going to multiply everything by 0.65. 750, 0.65. I also have to multiply my T by 0.65 because I multiply every term by 0.65. Then I add that to this side, so I get T plus 0.65 T equals 750 times 0.65. And that's basically 1.65 T equal to whatever 750 times 0.65 is. I divide by 1.65 to get T equals 750.65 over 1.65. T equals 1.39 times 10 to the 3 newtons.